Hey everybody, welcome. My name's Tom. This is the second video in a series of video on building a WebSocket game with Rust. Now, I will be going quite slowly. If you're experienced with Rust, you can just check out the repo or the article to get the bits that you are interested in. Otherwise, this whole thing is really just for me. I'm kind of been going through this. So I just want to build something totally from the ground up with Rust, that's the goal with this. I'm building a WebSocket based game. I'm hopefully going to be able to do everything in Rust as much as possible. I'm guessing since I want to put it in the browser, I'm probably going to have to do a little JavaScript just to connect things. But otherwise, I'm just going to be using Rust. Now, what we've talked about before is building the initial WebSocket server requires some stuff in order to do the handshake. And as I mentioned before, the handshake is client wants to talk to the server, so it sends something over to the server. Server validates that, sends something back, and then they establish a WebSocket connection. Part of that handshake involves the SHA-1 algorithm, which we did in the last video, and Base64. Okay, so what is Base64? Base64 is basically just these characters, and there are 64 characters. Just like ASCII has 256 characters, Base64 has 64 characters. And just like ASCII uses 8 bits or a single byte, Base64 uses 6 bits. And you might be asking, why do I care about Base64? What's it used for? Well, there's a few places it might be used. One, you are going to see it used in image tags, and that's probably the most common place you'll actually see it in your day-to-day. If you do any sort of web development, you might see somebody has in an image tag under the source just pasted a long string of characters that looks like this, and it probably starts off with some other little special, Base64 colon PNG type looking thing. And all that is just an image stored as Base64. It's encoded as Base64. Base64 probably, and don't quote me on this, but I'm pretty sure it's used in other places where the system doesn't have access to a full ASCII character set. It's maybe it's an embedded system or something like, it could even be a TV remote or some other place where you don't want to use the full character set. You don't need the full character set. You just need some sort of subset of it. So you have Base64 character set like this, and it's a very constrained system. So you just use this instead. And it sends 6 bits of information for every one of these characters. And we use that in our handshake for WebSockets. All right, so with that out of the way, kind of know what Base64 is. Let's start writing our, there we go. What is going on here? There we go. All right, sorry. Okay, so we're gonna start writing our module, and that module, of course, we're just gonna go ahead and make a Base64 struct, and then we're going to implement our Base64 struct. So we have a new function, and that is going to return a instance of Base64. So pretty easy. And since we're only implementing the encode and decode functions, I am just going to go ahead and put those in here. So we have encode, and I think okay, encode and decode, done. All right, so let's start looking at what we're gonna do with these. And we're gonna add some more stuff in here to these function definitions later on. But for right now, we'll just keep them like just really dumb simple, and we'll worry about them. Worry about the rest of it later. So what we're gonna need to do is we're gonna need to pass in our mute self. This is gonna be part of Base64. When I create an instance of Base64, like you'll see in just a minute, I'm gonna be able to want to do, my instance of Base64 dot encode and put some string in, and that's where we get our string, and our string is just going to be some string input. All right, done. All right, so let's head back over here. Let's take a look at what we might, how we're going to call this. So first thing we need to do is we need to have our module, and then we're going to say use base64, base64. And I'm going to say let, what do I want to call this? Make sure I kind of match up to the stuff I originally did. I think I can just call it base64. Base64 and new. All right, good. And now I can do something like base64.encode, and I can put in something. Okay, the only problem is this is going to complain that I am not mutable, because if you remember, I passed in mute self here. And if I don't pass it in, if I don't make this mutable here as well, then it won't let me do that, because I'm trying to modify it even though it's not modifiable, not mutable, sorry. So what we're gonna do in this algorithm is actually not super difficult. All we need to do is we need to take some string. So let's say our string is this, A, B, C, D, E. We need to take this and we need to turn it into bits, and then we need to take out 6 bits at a time and change them into the corresponding base64 value. So for example, this capital A, 6 bits is 6 zeros. It's the first one in here. And B is 5 zeros and then 1. And then C is, 4 zeros, 1 0. Okay, so it just goes on, it's just counting up binary wise all the way up to here till you get 6 ones. All right, okay, so pretty easy. The thing is, if you think about this, right here I've got 1, 2, 3, 4, 5 characters. 5 characters at 8 bits apiece, that's 40 bits. Well, 40 is not evenly divisible by 6, obviously. We're going to be able to take out 6 6-bit chunks, and we're going to have 4 bits left over. All right, so we're going to talk about how we're going to handle that in just a minute. But for now, let's just think about how we might take this string and convert it into binary so that we can chop off a whole bunch of 6-bit chunks and then convert them to their corresponding base64 values. So one thing you might be thinking about is, all right, well, I can just convert them straight to their binary, and I could just append all that binary stuff together. So for example, you pull out all of these bits and all these bytes, and you just append them together, and you get one really long chunk of binary, and okay, for all the way up to 60 bits. Okay, so you've got that, and now you're gonna store this. Where are you gonna store it? I don't know, maybe you just store it in another string. So you just have a really long string and you just chop off 6 of those at a time. And that would work just fine. You'd actually be able to do that, chop it off, convert it to a binary number, and then convert it to an integer really, and look it up, use that integer as an index in here and get that back, which is what we're gonna do. We're gonna use this as an index. So I'm gonna get a value 0. I'm gonna say, oh, 0 is this, and I get an A back, and I append it to some other list I've got. Now, the problem with doing this, say taking this and converting it to one long string of binary values, is what if we want to encode a gigantic file? So I want to encode, I don't know, some Blu-ray DVD rip I made, and I want to actually convert that to base64. Well, if I'm doing that, that's going to mean I'm going to have to make a string initially that is monstrous. It's going to be huge. It's going to suck up all my memory. Probably going to need to use, virtual memory, something like that. It's going to be a mess. So we actually want a better way to do this, because not only am I going to need to convert something into this gigantic string, I'm also going to need another thing to store the result that I'm turning into base64. So I'll have 2 giant things, one list or one giant string, and then maybe a vector with the ending bytes that I pulled out, or the 6-bit increments, whatever I'm looking at, the bytes that are going to represent this thing here. It's going to be way too much. So what I want is a way that just take the things I need, convert them, and then store them somewhere. So first thing I want to look at here is I want to look at a place to store all my information. So I am going to create something called encoded, and it's just going to be a vector. And this vector is actually going to end up being bytes, because we're going to be storing these actual characters here. These characters are bytes, so whatever we put in there. So this vector will be storing individual bytes. Oh, sorry, I need to put this here. No, wait, what am I missing here? Yeah, there we go. Something was going on there. I don't know why I need to put that there. This is going to throw an error. The reason this is an error is because it doesn't know what type this is yet. It's going to say, hey, I have no idea what this is. You need to annotate this. I'm not going to annotate this. I'm just going to let the compiler figure it out in a minute. You'll see that once I've assigned something to encoded, it will infer what I'm putting in there and assign it for me. All right. So the next thing I'm going to need to do is I'm going to need a place to, I'm going to need to convert this initial string into a format where I can actually get at those bits. I can't get at the bits of a string. I can't take a string and say, hey, in this string, I just want the first 6 bits of this string. It won't work. So I need to convert this into bytes first. So I'm going to convert this into bytes, and these bytes dot as bytes. There we go. These bytes, I'm going to be able to chop those up a little bit, and we'll look at how that's going to happen in just a minute. Now, as I just mentioned over here, if I were to make a really long string like this, it's going to be bad news, because if I have a really big file, I'd have a really big string. But I still need a place where when I say take out the A or the B or the C or the D from this string, and I convert it to bits, I need a place to store that, at least temporarily, until I can take 6 bits out of it and then convert it and put it into encoded. And what I'm going to use is I'm going to use a buffer. And this buffer I am going to declare as an unsigned 32-bit integer. All right, so this buffer is going to store chunks of data at a time. And I'm going to get those chunks of data from my bytes here. So when I said input as bytes, it took a string, okay? And what it did was it turned it into bytes, which is actually, if you look, it's an array of unsigned bytes. So everything becomes 1 byte. So I'm going to now pull out as many bytes as I can. Well, up to 3 bytes really. I'm going to pull out up to 3 bytes at a time, and I'm going to store those values in my buffer. So let's look at how we might do that. There's a really nice function. Oh, for chunk as bytes. Oh, sorry, thinking something else. In bytes dot chunk 3. Okay, so this function, this here, that we're going to call for bytes, it's actually really handy. Chunk will take up to 3 bytes from my bytes here. So they take a chunk of this array, and it's going to take up to 3 whatever chunks that I have. So in my case, these are byte chunks. So it takes 3 bytes out of my bytes array, and it gives me this chunk back. And this chunk is going to have, in our case, either 3 bytes, 2 bytes, 1 byte, or no bytes. If it's no bytes, it's just going to end the loop. Right? But if it's 3, 2, or 1 bytes, then I want to do something with it. All right, so let's look at what we're going to do with it. We're going to want to put the result somehow in our buffer. And this is where things start to get a little bit tricky. So let's assume that I have a buffer here. Let's see. Let's do 0 and do. Oh, why did I do that? No. Having problems here. All right, so let's say I've got my first byte in here. This 32. Okay. Actually. Yeah, all right, it's fine for now. Actually, no. Let's see. 16 word. Is that right? Yeah, okay, good. Okay, so I've got my 4-byte chunks, sorry. 4-byte chunks here, and I've got 32 bits. For the buffer, I now want to actually stick something in there. So to do that, I am going to take this chunk and I'm going to determine how many particular chunks I have. So I can have up to 3 chunks. Let's why is my, there we go. Okay. Buffer chunks. This is going to complain because I don't have anything in here. I can do this. We'll just do this first. Boom. There. The problem is I can have 3 chunks. 3 chunks, 2 chunks, or 1 chunk, or this here. All right, so in a match statement in Rust, you need to make sure that you've covered all possibilities. In our case, this underscore just means anything that's not 3, 2, or 1, we give it 0. This will never happen. Buffer will never ever get 0 because when we do our loop, if it is 0, or if it's only going to have 1, 2, or 3. If it's 0, the loop ends, so it's actually never going to hit that. We're matching on the length of this chunk, and if we have, for example, 1 byte in there. Now, why would we have only 1 byte in there? Well, if you look at this, I'm going to grab 3 bytes at a time. And then I'm going to grab 3 bytes at another time, but I only have D and E, so actually it's going to hit 2 bytes. If I had an even number, like if this went up to F here, sorry, even as in the sense I have, multiple chunks of 3, it would be 3 bytes. If I had A, B, C, D, it would only give me 1 byte back. All right, so we'll stick with this. What we're going to do now is we need to figure out how we're going to put it in our buffer. Whatever we're going to match here, whatever this is, it's going to go into buffer. So let's look at how we're going to do that. I'm going to do an unsigned integer 32 because my buffer is an unsigned 32-bit integer. I'm going to convert from my chunk, right? And it's going to grab the first chunk out of there. So in our case, if I have 1, there's only going to be 1 thing in there. And then I'm going to shift 16 bits to the left. So this is a little confusing if you've never seen bit shift operators before, but let's assume that the first bit, the first thing I want to put in there is going to be this binary value. Okay, so let's say I'm going to put this binary value in there. I want to put it inside this here. All right, so if I'm going to shift it, I'm shifting actually from the right side, not the left side. It always shifts in from the right side. And I'm going to take this value. I'm going to pretend like I, stuck it right here. And I am just going to shift it 16 times to the left. So I stick it in, boom, I've got this value. I'm going to shift it over to here. Okay. So basically what's happening is I'm taking this value and I'm shifting it over 16 times, and I'm going to put it inside this buffer. So this buffer becomes equal to that. So say this is the buffer originally. I now have this value. This value at this point okay, is equal to this. All right. And I'm going to take this value and I'm going to shift it 16 times to the left, which means actually what I'm doing is this. Okay. That's what's going to happen. So this gets put in here and it shifts all the way over. All right, that's fine. That's what I do. And then I assign it to buffer, and then I'm gonna do something with it. But before we actually see what we're gonna do with it, let's see what happens if we actually have 30, if we have 2 bytes. Okay, so I grab this. I'm just gonna put this in here like this. This time, we still take the first one and we put it in 16, but let's say that the second number I want to stick in is gonna be this. Let's do, okay. All right, so let's say I've got this value. All right, now I want to be able to put this value in and this value in, because I'm actually, if I have both these, say I were to take this and this, I'm going to shove this one in and it actually will get put right here. Okay, and this one will get put right here. Okay, so this shifts in 8, this shifts in 16. All right, so you're kind of seeing the idea here that these just are getting shifted in one by one. And of course, if I had another value at the very end, and let's say, I've got 0, 1, 1, 1, something like that, cool. I would do exactly the same thing, but this time I am going to, take 2, and I'm not actually going to do anything with it. What am I missing here? There we go, from chunk. There we go. Oh, I know what I'm doing. Oh, there we go. Okay. Why am I getting an error? Interesting. Can I mute? Oh, bop. Done. All right. Sorry, needed to make buffer actually mutable. All right, so we've got these 3 different possibilities here. And one thing here, I don't know, it's kind of interesting that this dumped it to the next line like that. We've got, if we have 3 bytes, we're going to shift each one of these over. This value just gets stuck on the end. This value gets put in first of these chunks, and it's gonna be pushed all the way over here, then this one, then this one. And for each one, they'll end up being a little bit different based on what we're looking at. So let's walk through what this does. This part's the shifting. I think we talked about that, just shifts everything over. This here is an OR operator. And it's a little confusing what's gonna happen. So what actually happens is this. Say we start off with this first one, I shifted it in 16 times, right? Each one of these is a separate value. Actually, what this looks like, if I were to, let me copy these here, dump this down here. Looks like this. That's just easier just to pop it in. Okay, so actually it looks like this. I've got this value, this value, this value, and the OR here is just kind of just, it's, well, really all it's doing is an addition. If you're not familiar with like Boolean logic at all, AND, OR, and stuff like that, when it comes to bits, it's okay. Just think of this as saying, all right, if it's a 1 or a 0, take the 1. If it's a 0, 0, take a 0. If it's a 1 or a 1, take the 1. So this is just adding these down, and we're going to get this at the end. So it's concatenating them together, all right, and creating our final buffer. All right, so that's all that's happening here, is we're taking this and we're getting our buffer, and now we have this unsigned 32-bit integer with a bunch of data in it, a bunch of binary data that we can manipulate. So let's look at how we're going to convert this now into Base64. What I want to do is, with this, is I'm going to be looping, I'll make a variable for this. So So this is the number of characters we're going to output, and it's actually just the same as the length plus 1 for the loop I'm going to make here. And the reason I'm going to just make this is just I'm not writing, you know, chunk.length more than one time. It's just cleaner, I think. All right, so if we have for I from 0 to 4. So why am I doing from 0 to 4? Well, if I have 24 bits here, that means I can get 6 bits for each base64 number, meaning I can get 4 base64 numbers out of there. So if I go 3 total bytes, then I can take this and I can break this into 4 chunks of 6 bits, and each 6 bits is going to correspond to one of these base64 characters. Okay, so I'm going to loop through from 0 to 4, and I'm only going to do that. I'm going to say if I is less than output characters. Okay. You might be wondering, why don't I just loop for the number of characters I have? And you'll see why in just a second. It has something to do with what I talked about earlier, where if I end up with 2 bytes or 1 byte. Now, think about when am I going to end up with 2 bytes or 1 byte. The only time that's going to really happen is when I get to the end of my string that I'm encoding, because otherwise I'm always going to be able to grab 3 byte chunks. All right, so I'll be able to grab 24 bits at a time until I get to the very end where I don't have enough. If it's not an even number as I go through, then I'm going to get to the point where I might have, you know, 1 or 2 bytes remaining. Okay, so if I is less than the number of output characters, so for example, in our case, if we're just doing a normal one, I will always be less than the number of output characters because this goes 0 up to 3, right? So it'll always be less than our number of characters. So what we're going to do for this is pretty simple. We're going to calculate our shift value, okay, times 6. So this shift value is going to tell us how much we're going to shift everything over. Okay, and we're going to get this. We're going to take a temporary value and we're going to shift our buffer, and we're going to shift the buffer according to our shift value. So let's think about what this is going to look like here. If we're in our first loop, that means I is equal to 0, right? And 0 times 6 is going to leave me with 18. And that means I'm going to shift to the right this time 18 bits. So if we're going back to our early example here, I've got 24 bits. If I shift 18 over, all right, let me jump this down here. So let's see. If I shift by 18, what am I actually left with? Well, I should be left with just this, okay? And there'll be 2 zeros here in front of this because I've shifted 18. So I'm left with this. This is just the value that is going to be the furthest bits I have to the left of those 24 bits. So I'm actually going to be taking out the first thing that I shoved into my buffer, my unsigned, my buffer up here. So I'll take those 6 bits on the far left, okay? And I'm going to take those 6 bits, and the first thing I'm going to do is I'm going to take them and I'm going to convert them into a index value. So this index value here, this might be a little confusing what I'm doing, but I'm actually doing an AND here. And this is the, instead of concatenating things or really just saying I'm adding down here like this, what this is doing is it's performing an AND to make sure that everything in temp is going to be cleared out, except for whatever happens to be in the first 64 really, or I could change this to a binary number and I could say put 1111 here. So let me give you an example of what this might look like. So I've got a bunch of things here and I'm anding it to 63. So 63 as a binary is this, right? If I come up here and I grab this and come back here and put this here. So I've got this number and this number. If I and these two together, what that means I'm doing is it's saying if it's a 1 and 1, give it a 1. If it's a 1 and 0, give it a 0. If it's a 1 and 1, give it a 1. So basically all that happens is anything that's here comes down here. So this is actually still going to be equal to this 1 0 1 1 1 0. Why would I want to do that? Why not just stick it in and trust that I have something going on? Well, there is a possibility that maybe somewhere, it's not likely, but it's possible that you have some sort of errant numbers off to the left somewhere. And so this value will not actually be less 63 or less when you're done with it. So for example, let's say in this, maybe I had a 1 over here or something. Like I had all of this and then all the way over here, there was a 1. If I try to convert this into an index, it's not going to be valid. So this is kind of clamping the size down and making sure that this is, so this makes sure that it's 63 or less. Okay, so it makes sure that the index is less than 63 or less. All right, and once I have that index, then I can just do the following. I can say push, and I take my base64 character set, and I can say index, and I'm done. All right, so awesome. That works just fine. We can convert everything that we want. The only thing is we haven't handled it if it's 2 or 1, because what happens if it's 2 or 1? Let's say if, for example, I only have 1, I'm still going to loop 4 times here. What happens if in that case the output characters is incorrect? Okay, so else I'm going to say encoded.push bytes like this. And this is the padding. So this padding here, all right, so this padding needs to be added on at the end of our base64 number. So if we don't have an even number of 24-bit chunks. So every number that we convert in base64 is either going to have no equal signs at the end for padding, 1 equal sign, or it's going to have 2 equal signs. All right, so that's it. So it's just going to have the additional padding at the end. All right, so that's the last little bit for our encoding thing. And that's it. So let's walk through this again. What we kind of do is we grab 3 chunks, 3 bytes at a time. We shove those bytes into our buffer as much as possible. We then loop over that buffer and we pull out, starting from the left side this time. This is coming in from the right side, and then we take the leftmost 6 bits, we convert them to an index, we push that onto our encoded vector up here, and you notice there's no more error anymore because it now knows that it's pushing bytes on there, and then we're done. Okay, so we push that on, but we haven't returned it yet, so we need to get to that. And what I'm going to do, I'm going to make this a little bit easier here. I'm going to go ahead and delete some of these lines here so we can then come back up, and we're going to put on something a little bit different actually. So this can fail if, for example, when I convert at the end to base, or encode it rather at the end. So what I need to do is I'm going to return, actually I don't need to return anything, I can just do this. String from, let's see, UTF-H, right? Yeah, that's what I want. I'm going to take this encoded, it's going to convert our byte vector, and it's going to convert it, or if it can't convert it, it's going to say that there is a base64 error, UTF-8 error. Cool. All right, now we're going to get some errors because we don't actually have this error type. And we're going to use this error type in our decode and in encode. So we're going to create a new base type up here. And I'm just going to go ahead and just grab that. Oh. Okay, paste it in there. Yeah, let's put this at the top. Boom, boom, boom. All right, so what's going to happen here is I've got this Base64 error type, and it's going to have two different errors. One is the UTF-8 error, which is when we're encoding UTF-8 to UTF-8 from our encoded Base64 sequence, or an invalid character, which I haven't used yet because that's going to be when we're decoding if I give a string with an invalid character. The other thing I need to do is I need to actually be able to display some sort of error value. So I'll show you what I mean by that. Right now, this is going to be saying, all right, I've got this encode, but look, this just gives me an unused result. So let's just say, actually, let's do this. If I get an encoded, encoded equals E. All right, cool. Let's say I do have an encoded value. We're all happy. Let's say there's an error. What do I do with my error? Well, normally you'd want to display it as some sort. So I might want to panic, okay, and I might want to display my error. The problem is here, oh, I got this here. Here, I have no way to display my custom error type. All right, now I could just get rid of this and I could just return, I don't know, false or whatever, or -1 or something like that. But I want to do it a little bit better here. So what I want to do is I'm going to define my error type, and I'm not going to go over these too much on how this stuff works, but I'm going to put this in here and I'll walk you through it. So this needs a way to be displayed. This here is expecting this value to implement the display trait so that it can properly display this on the screen. So when it panics and it gets this and I'm trying to pass this into here, it says, hey, how do I actually show this value on the screen? Well, you do that by implementing the display trait for this particular enum. Okay, so I use it here. If I return an error, for example, if this returns this error, in this case, it's going to refer this to the built-in UTF error that's already in the standard library. I said we're only going to use the standard library for this, so not cheating or anything. And it's just going to go ahead and format that error type for us. So we're going to get this already kind of free. Invalid character is a little different. I'm going to use write here. It's going to write this to the screen, write the error that I get for that. Okay, so it's going to send the formatter. I get that. It's going to display this error, and we'll see that here when we try to decode something that doesn't actually work. All right, so let's actually test this. All right, we're going to do this. What do we got? We got encoded. Yeah, encoded. Cool. All right, and if we run this, cargo run, we're going to get some warnings. That's fine. And you're going to see that I get this Base64 number here. These warnings, we just haven't used these yet, so don't worry about those. They'll go away when we're done. And it works. So we get our Base64 value out, and you can go test that for yourself if you'd like elsewhere. All right, moving on. Next, we need to do our decode. And now that we've actually done encode, it's going to be a lot easier. I'm going to pop this down here. I'm going to replace this. I'm going to do this to owned, just so that I can get some, oh, I need to get that. All right, cool. So this is just a placeholder for now. Don't worry about this OK statement. It's going to go away. The OK is going to be replaced by a statement similar to this one when I convert the value. All right, so now we're going to actually do the decoding. Decoding, almost exact same process, just kind of in, well, not exact same process, very similar process, but in reverse. All right, so what we're going to do is we are going to do something very similar. We're going to have decoded. We're going to make, let me just grab these actually, because we're going to have, actually, no, we're not going to have basically the same thing. Okay, so we got decoded. We are also going to have a buffer, and that's still going to be U32. And this time we're going to have another thing called bits collected, and that's just going to start at 0. Okay, so let's walk through how to do this. We're going to get some sort of string. So let me... let's see. So let's say I'm going to decode this string here. We do the exact same thing that we did before. Okay, and we want it to work just fine. We decode this. What we're actually going to want to do is we're probably going to want to throw this encoded value in there. Let's do that. So we encode it, we print it. Oop, I didn't get rid of my print statement here. Okay, cool. All right, so we're going to encode, then we're going to decode, and hopefully it prints out the same in the end. All right, so let's go ahead and go through this. So first thing I want to do is I want to go through all of the characters in my string. So hopefully this is pretty evident. I want to go through each character in my Base64 string one at a time. Bum, 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 bum. I want to take those and I want to look them kind of back up in this table up here, right? I'm going to then take the value from this table, say it's 90, or sorry, say maybe it's 0 up to maybe, I don't know, 43 or 2 or whatever. I want to convert that to binary, and then I want to stick it in and turn it into a byte. But I have the same problem that I had when I was pulling bytes out and turning them into 6-bit chunks. Now I have a byte and I want a 6-bit chunk, and I'm going to need to turn that into a byte. So I'm going to need to get multiple chunks together, and then I'm going to need to take out 8 bits at a time and convert it to an ASCII character. All right, so first thing I want to do is I'm going to need to get out where this value is in the index. So this is the position of this in here. Okay, so it's the location here. Let's just change that to index. So we have some sort of, I don't like that because it's using, yeah, we'll use that because it's using position on that other one. So then we're going to match on that position. So very similar setup that we had before. But when we match on position, it's going to be a little bit different. So what position returns is it returns an option. So if it doesn't find this, and what this is doing here is it says, all right, iterate through my entire list up there, find where X is equal to C. So whatever the value I'm currently looking at, does it equal to C? If it does, then give me that position. Okay, so it's just finding the location of C, which is hopefully a Base64 character from up here. It's going to go through this, find the index in here, and it's going to return that index to you. Okay, so I'm going to match on this, and I'm going to return either some value or none. Okay, and if I do return none, then I can return an error type, and that Base64 will be an invalid character. Now I get to use that. All right, so if you don't remember what options are just basically saying I'm going to find something, or I'm not going to find anything. If this value is not in my Base64 character set, it means it's not a valid Base64 string, which means that I can go ahead and bail and stop trying to decode things. But if it is a Base64 character, then I need to do something with that. And to do that, I am going to do the following. I'm going to take my buffer. I'm going to shift everything in the buffer 6 to the left, and then I'm going to concatenate that position as a U32. Okay, so my buffer starts off empty. I'm going to shift everything 6 to the left. And then I'm going to stick this thing in here. I'm going to add it. I'm going to concatenate it onto the end of this buffer. All right. So this is the OR operator again. It's going to put everything that was previously in the buffer is going to already be there as well. Okay, so this, think of it as I'm taking 6 bits, I'm shoving it into the left, taking another 6 bits and shoving it into the left, and so on. Okay, that's all we're doing. And bits collected is going to be plus equals 6. So that means we've collected 6 more bits in our buffer. We're going to do that. And we're going to say while bits collected is greater than or equal to 8. Now, honestly, like, it's never going to be, if it's equal to 8, it's fine. If it's either going to be a little bit over or a little more over, but it's never going to be, you're never going to fill the buffer, because if you shove 6 bits in and you shove another 6 bits in, you're now already over. So you're going to end up triggering this. So it's either going to be 8, it's going to be 12 bits in the buffer. Sorry, it's going to be 6 bits or 12 bits in the buffer. Then we're going to say bits collected minus 8. Sorry, 10 as well, I guess. We're going to subtract 8 out of there. We're going to take our byte, and this time we are going to shift the number of bits we collected to the right, which is going to be 8. I could write 8 in there as well if I wanted. And then I'm going to, again, use an and I am going to make sure that whatever byte I have in there, that I've cleared out any of these errant values so that I only have the number that I'm looking for. Okay? It's basically a mask. It's masking the values using the and. Okay? All right. And then the last thing I do is decoded.push. And I put that on as an unsigned bit integer. What am I missing here? Boom. I need there. Cool. Sorry. It's a hexadecimal number. Put it in like that. All right. So let's walk through this a little bit here. We've got the buffer, getting an error on my buffer for some reason. Why? What do I need to do? Oh, I need to initialize the buffer this time. So the buffer needs to be what do I need to do? I can do this. All right. So buffer is going to be, let me just do this as well, right? There we go. All right. Shouldn't be any difference between those. This makes this a little bit more readable, I think. All right, so we're going to go through every character. So say I have my AB, so I have whatever this comes out as, I can't remember. It comes out, say it's a capital A. It's going to look through the Base64 character set, find that capital A is equal to 0. It's going to pull out match on that position then. So match just basically is going to match, do I have something or not have something? If I do have something, we're going to take it out. We're going to do something with it. We're going to take those 6 bits, whatever happens to be, and we're going to shove them into my buffer starting on the right. It's going to shove 6 more bits in. We're going to keep track of how many current bits we have collected. We have no way of doing like a dot length or anything because, well, it's an integer. There's no way to do a length on a single integer. We're then going to say while those bits are greater than or equal to 8. So if we're collecting those bits, if we have more than 8 or more, we need to take out because we're now converting back to bytes as opposed to 6-bit chunks. So those 8-bit chunks, we're going to take that 8 bits out. We are going to shift the buffer to the right to remove 8 bits. And we're going to then AND the whatever comes out with a byte of all ones. This is going to be masking that to get our byte back out to make sure that there's nothing left in this U32 value that might be, some errant value past those initial 8 bits. Then we're going to convert that value here into a byte, and we're going to push it onto this. And then the last thing we need to do is just return it. So I can get rid of this, and the string value should be same thing from UTF-8, and instead we're going to put decoded in here, and we're going to map air, and this time it's going to be Base64 air, same thing, UTF-8 air. Okay, and it returns that value, and that's it. We've now done this. We are ready to go. We've got the encoded, decoded parts. We should be able to go ahead and run this. Cargo run. There are no errors. Oh, I've got an error. All right, invalid character and input. Let's see what that happens to be. So I have some invalid character in my input. How's that possible if I'm putting back in encoded? All right, so, oh, okay. I think I forgot to do one thing here. What I need to do, oh, okay. So if C does not equal sign, yeah, okay. We don't actually, oh, I don't even need to put that in there, do I? We don't want to decode the equal sign. So it should actually work if I do this, cargo run, and we get ours encoded, and we get our decoded right back to what we started with. And that is about it. All right. Thanks for bearing with me through this video. I hope you actually learned something. There is an article that goes with this. I do explain some other stuff like how to do tests and things like that for this particular module here. I think actually the article is probably a bit more detailed in different areas and some better examples perhaps. But I like making the videos, just good practice for me and helps me get stuff out there. All right. If you got any other questions, leave them in the comments below. Check the description for other related stuff like the repo and things like that. And have a good one.